Hello everyone, myself Kalaiselvi. I am working as an assistant professor in the Department of Mechatronics Engineering, SNS College of Technology. In today's session, we will discuss an important topic in electrical drives and control, that is speed control of DC series motor. So as we know, DC series motor are widely used in applications requiring high starting torque and variable speed operations, like electrical train, cranes, and traction systems. So, however, different industrial applications require different operating speed. Therefore, controlling the speed efficiently while maintaining torque and minimizing energy loss becomes very important. So, in this lecture, we will understand four major speed control methods, that is flux control, voltage control, armature resistance control, and PWM control. Okay. Before discussing speed control method, let us quickly revise the basic characteristics of DC series motor. In a DC series motor, the field winding and armature winding are connected in series, and the same current flows through both the armature and field winding, which produces a very high starting torque. The motor speed varies according to the load conditions. An important characteristic is speed is inversely proportional to the magnetic flux. This means when the flux decreases, the speed increases, and vice versa. Because of these characteristics, DC series motors are ideal for heavy duty applications. Okay, so let us think from an engineering design perspective. When designing a drive system, we need to consider required operating speed, load variation, energy efficiency, and cost of implementation, then reliability of operation. So the challenge is to achieve smooth speed variation while maintaining sufficient torque and efficiency. So different applications demand different control methods, which is why several techniques have been developed. This all achieved by the design thinking concept. So this is the overview of speed control methods, that is flux control, voltage control, armature resistance control, and then PWM control. Okay. So the first method is flux control, also called as field weakening method. In this method, a diverter resistance is connected across the field winding. So part of the current bypasses the field winding, field current decreases, and magnetic flux also decreases, since motor speed is inversely proportional to the flux. So the speed increases when the flux decreases. This is in the flux control method. The main advantages of this flux control is circuit is very simple and cost implementation is very low, and then smooth speed variation. The second method is voltage control method. In this technique, the supply voltage applied to the motor is varied. The armature current changes according to the voltage applied to the motor. So the motor speed changes proportionally with the voltage. Therefore, higher voltage produces the higher speed, lower voltage produces the lower speed. The main advantages of this voltage controllers, it has good speed regulation, high efficiency, also smooth speed variation. Okay, the third method is armature resistant control. Here, an external rheostat is connected in series with the armature circuit. Total circuit resistance increases in this method, and the armature current decreases when the motor speed decreases. The main advantages of this third method is the circuit arrangement is very simple, and the cost of the implementation is also low, easy to understand and maintain the armature resistant control. So the main disadvantages is it has the large power loss occurs in the rheostat, and also it has low efficiency. Because of this energy wastage, this method is generally limited to temporary speed control and educational demonstrations. The final method is PWM control. The most advanced technique is pulse width modulation control. which controls the motor by applying the high frequency voltage pulses, varying the pulse width or duty cycle, and controlling the average voltage supplied by the motor. For example, 20% of duty cycle has the lower average voltage with the lower speed. 80% of duty cycle has higher average voltage with a higher speed. This allows very accurate speed control. It has some advantages, that is excellent speed regulation, precise control, like minimal power loss, very high efficiency likewise, and then it is mainly suitable for the automation. This PWM control is used in the electric vehicle, robotics, and then smart motor controller, industrial automation systems. So this PWM is currently the preferred method in modern drive system. Okay, though when selecting a speed control technique, engineers should consider the cost effectiveness and then speed range, load characteristics, also required efficiency, complexity of the implementation. So for simple application, flux control or armature resistance control may be sufficient, but for industrial system requiring efficiency and precision, voltage control or PWM control is preferred. This is the application of DC series motor, which is used in electric locomotive, cranes, and then material handling systems, IoT enabled motor control, AI based speed optimization, smart condition monitoring. So likewise, these are the applications of DC series motor. uh, Now let's conclude and let us summarize today's discussion. DC series motors provide high starting torque and variable speed operation. Therefore, four major speed control methods are there, that is flex control, voltage control, armature resistance control, and PWM control. PWM offers the higher efficiency and precision among the modern control techniques. Proper method selection depends on the application requirements, cost, and performance expectations. So, this is about the DC series motor of starting methods, I mean speed control methods. In this next session, we will continue exploring advanced electrical drive control techniques. Thank you.